This is Christian Arguelles from 2050 from Planet X. We're sending this message back to you in the past so that you can study calculus more and easily. I hope that you enjoy.
Are you ready? Okay, now let's talk about area of region in polar coordinates. Now, we turn our attention to deriving a formula for the area of a region bounded by a polar curve. Recall the proof of fundamental theorem of calculus use the concept of a Riemann sum to approximate the area under a curve by using rectangles. For polar curves, we use the Riemann sum again, but the rectangles are replaced by sectors of a circle. Now consider a curve defined by the function r equals function of theta, where alpha is less than or equal to theta, which is less than or equal to beta. Our first step is to partition the interval alpha, comma, beta into n equal width subintervals. The width of each subinterval is given by the formula change of theta equals quantity beta minus alpha over n, and the nth partition point theta is given by the formula theta equals alpha plus change in theta. Each partition point defines a line with slope tangent theta passing through the pole as shown in this graph. And now you can see two line segments that are connected by arcs of constant radius. This defines sectors whose areas can be calculated by using a geometric formula. The area of each sector is then used to approximate the area between successive line segments. We then sum the areas of the sectors to approximate the total area. This approach gives a Riemann sum approximation for the total area. The formula for the area of a sector of a circle is illustrated in this graph. Now let's recall the area of a circle. It is pi r squared, right? When measuring angles in radians, 360 degrees is equal to 2 pi radians. Therefore, a fraction of a circle can be measured by the central angle theta. The fraction of the circle is given by theta over 2 pi. So, the area of the sector of this fraction multiplied by the total area. And so after using Riemann sum that approximates the area, we take the limit as n approaches infinite to get the exact area. Suppose f is continuous and non-negative on the interval alpha is less than or equal to theta, that is less than or equal to beta, with 0 is less than beta minus alpha, which is less than or equal to 2 pi. The area of the region bounded by the graph of r equals function of theta between the radial lines theta equals alpha and theta equals beta is this. You may always go back to the beginning of the video to review the process and the steps and the formula, because you know what's gonna be next. Our example. I know that you're ready. Now find the area of one petal of the flower defined by the equation r equals 3 sine 2 theta. I believe that you paused the video to do it by yourself, and when you're done and you're back now, here's the answer for you to be able to check if you did great. This is gonna be the last video that we'll be sending you for this decade. Please expect more messages from us from the future. I hope that you enjoyed those 4 lessons from us. Thank you so much for listening, and we're gonna be contacting you in the next decade.